Yes, so this is day two of our system Verilog course where we are going to start with our data types, right? So coming to our Verilog data types, we only have four state data types in our Verilog, right? So, but in system Verilog, we have both four state data types as well as two state data types, right? So in our system Verilog, we have two state data type and four state data type. Now, what do you mean by four state data type? Four state data type is nothing but 0, 1, x, and z. So a variable can take all these four values 0, 1, x, and z. And in the case of your two state data type, the variable can have only two values, which is 0 and 1. Okay. So this is nothing but the difference between your four state data type and two state data type. Okay. Now, so coming to our four state data type, let us start our discussion about our four state data types. Okay, four state data types in our system Verilog. Okay, so the very first four state data type which we are going to discuss about is logic. Okay, so we have one new data type in our system Verilog which is known as logic. Okay, we are going to discuss about this particular logic. What do you mean by logic and all? Now, so before going to discuss about logic, I wanted you to know a few things from our Verilog. Okay, so we have something known as procedural statement, or you can also call it as procedural block and continuous block, or you can also say assignment. Right. So, can anyone tell me what do you mean by procedural block? Like any example of your procedural block? Yes, exactly. Always block and initial block. These are all procedural blocks, right? And coming to your continuous assignment blocks, these are nothing but your assign block. Okay. And this is nothing but your always block and initial block. Am I right or wrong? Yes or no? Yes. Okay. Now, let me write down a simple code and let's see who can find out the bug in that. Okay. So from the day one or day two, we will start finding out the bugs. Okay. So let me share my screen. We are going to use a open source tool, which is known as EDA Playground. Okay. So first of all, let me show you how we are going to use this EDA Playground, so that if you are a new one who don't know about this EDA Playground, you can able to get an exposure to that, right? So you can just go to Google and type EDA Playground, okay, and you will open this particular website. Now you can just log in it with Google. So you can just log in it with your Google account. Let me wait. So it is getting open. Yeah. So after you have turned on this particular EDA Playground, on the left hand side, there is one option which is known as languages and libraries. Okay. So you don't need to change anything. It is by default system Verilog. Okay. And UVM, since we are not using this UVM libraries and all now, this you can keep it as none. Okay. And you don't change anything. It's not necessary. And in the tools and simulators, you just click Altec Rivera Pro. Okay. And you select this simulator. It's a free simulator we are going to have. Now, so let me write down a simple Verilog code, which is module example, and let me declare a simple input AB, output XY. Assign X is equal to 0, initial Y is equal to 1. Okay. So my question here is this code correct or wrong? The whatever the code which I've written here is correct or wrong? Okay, beginning we will use if we are having multiple lines of code. We don't need beginning if we are going to write one line of code. Okay, I will share my screen 1 minute again. You can see this and you can tell me 1 minute. Yeah, hope my screen is visible, right? Mm. Now tell me. So you can take your time and tell me what is exactly the error is, what is the bug is. Okay, I'm getting few responses already. Initial can't be synthesized. Nowhere I have said that I want to synthesize this code. I haven't written any begin, so no need of end. Okay, I got a few correct answers. Exactly. Yeah, I'm getting few correct answers. Yes, 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 yes. Okay. And what about others? Okay, for process block, output should be rich. Exactly. Okay. I will share my screen 1 minute. So what is happening here is, if you are using a procedural block, the rule is on the left hand side, you need to have the variable of reg data type, okay, or any other integer data type. But you're not supposed to use net data type, okay. LHS can't be net data type, okay. LHS can't be of net data type. And in the assign block, let's say if I'm going to declare output reg x comma y, then here in the assign block on the LHS side can't be reg data type. Okay. So on the LHS side, you are supposed to use only reg data type. Sorry, you are supposed to use only net data type, right? So this is a confusion. Many freshers get this type of confusion. Like on the left hand side of your assign block, shall I use net data type or shall I use reg data type? Or in the procedural block, should I use reg data type or net data type? Like if you are learning Verilog for the very first time, yes or no? Anyone facing this particular type of confusion? Okay, I think you are all very brilliant. Okay, okay, yeah. Okay, okay. So, to avoid this particular type of confusion, SystemVerilog introduces a new data type which is known as logic. Okay. So, what is this logic is? So, if you use this logic data type can be used both in procedural blocks like your initial block as well as your always block, and it can also be used inside your continuous assignment blocks like your assign block. With your assign, you can use logic data type. Okay. So let us see. So as soon as I've given this example, so I've seen many people doing this. Let me show you what they do is logic x, and here they will write x is equal to 1. Now in interviews, normally we have seen in many interviews also, I've seen in many interviews. So I've asked people to just give a demonstration of logic data type. So explain a logic data type, write down a code for logic data type. So they usually write this particular thing. Now, is this code correct or wrong? Yes or no? What do you think? Is it going to work? Yes, exactly. To avoid confusion between reg and wire in Verilog. So, okay. So, whenever I've asked some candidate in an interview to give a demonstration of logic data type, write down a code snippet for logic data type, they usually write this kind of examples. Now, is this code correct or wrong? Whether it is going to work? See this and let me know whether is it going to work. What will be the value of my x? Okay. So if you carefully observe here, your assign block and initial block are going to work parallelly. Okay. Since Verilog and SV is also a concurrent language if you are going to use modules, right? So here, these two are going to run parallelly. So it's syntactically correct and your syntax and everything is correct, but its behavior is wrong, right? Because these two are going to run parallelly and your value of x is nothing but don't care. Am I right or wrong? Yes or no? Is it clear? So if you want to give an example of logic data type, you can take two variables and you can demonstrate using that particular thing. So it's a small point to remember so that if you are in your interview in panic, we do this small kind of mistakes that we can avoid it. Okay. Yes. So is it clear for everyone? Yes or no? Please let me know in the chat box. Here y value will be equal to 1 and x value will be equal to 0. Okay. Yes. So is it clear for everyone? Yes, initial will run at the start of simulation at time t is equal to 0, and assign will also start at time t is equal to 0 itself. Both the blocks will run parallelly. Okay. Yeah, it runs only one and it is going to give x. Okay. X is don't care. Just now I told, right? When x is in both the blocks, then x is don't care. X is x only. Okay. Yes. So is it clear for everyone? Yes or no? Shall we move forward? Yeah, that is what. That is the same question. So that is what I am saying. Logic can be used in both procedural and continuous assignment blocks. This logic can be used in continuous assignment block and procedural block. So as soon as we told this particular definition, what many will do is they will declare a single variable and they will use it in both blocks. And if you carefully remember, in Verilog also we have discussed this particular thing, both these blocks will run parallelly. So if parallelly at the same time you are going to drive you are going to drive multiple values into a same variable, you are going to get don't care. Okay. Yes. So I think this is clear, right? Yes. So we'll move forward. Okay. Now, so coming to the default value of this logic, so what is the default value of this logic? Can anyone tell me? Okay, what is the default value of your ridge? Default value of reg is x. Exactly. So default value of reg is x, and same the default value of your logic is also x. Okay. So it's don't care. The default value of your logic is basically don't care. And your logic is also four state data type that it can support 0, 1, x and z. Okay. So the main points to remember in this particular logic data type is it can be used in both procedural blocks and continuous assignment blocks. And it the default value of this logic is x, and the default and this logic can support four variables, that is 0, 1, x, z. So it can have the values of 0, 1, x and z. Okay. And is reg a synthesizable or non-synthesizable construct? Is reg a synthesizable or non-synthesizable construct? Reg in Verilog. Exactly. So reg is basically synthesizable. Reg is synthesizable. Okay. And logic is also synthesizable. Okay. So here logic is also synthesizable. Okay. So this is about your logic data type. I hope the logic data type is clear, right? So shall we move forward? Any doubts or any queries in this? Yes. So in system Verilog also we can have in system Verilog also we will have the data types like reg, wire, integer. Yes, we can also use integer and we can also use logic. Okay. All the data types which are present in Verilog are also present in our system Verilog. Apart from this, all the data types which are present in Verilog, we have new data types like logic. Okay. Yes. Now coming to two-state data types. Okay. So this two-state data types we have uh, let me write down. So we have bit, byte, shortened, int, and long int. Okay. So these are nothing but my two-state data types. Now, what do you mean by two-state data types? So basically, two-state data type in the sense. So you are going. This particular data types can have only two values, that is zeros and ones. Okay. So two-state data types in the sense they can have only two values, that is zeros and ones. Okay. So let us start with this first data type, which is bit. Now, so my question is, what do you think the size of this bit data type? The size. What do you think the size of this bit data type? Bit data type. Logic or edge, it depends on the compiler to choose, can't be both at a time if not wrong. I didn't get your question. Okay. So this bit is basically one bit, as the name itself suggests, right? So it can only hold either 0 or it can either hold only 1. Now my next question is whether it is signed or unsigned. Bit data type is signed or unsigned. What do you think? Exactly. Using a single bit, you cannot represent a signed numbers, right? Okay. So obviously it's unsigned. Using a single bit, you can only you cannot represent signed numbers like negative numbers, right? Okay. So this is unsigned. Okay. Now my next question is, what is the default value of this bit? What do you think? Exactly. So the default value of this bit is 0. Okay. The default value of this bit is equal to 0. Okay. So let's say if I'm going to declare a bit like this, bit A, and if I'm going to write down A is equal to tick binary X, and if I display the value of A, if I display A, what do you think that is going to be displayed? If I display this A, what do you think that is going to be displayed? Okay, let's check it out. So let's say if I'm going to have a module and if I'm going to declare a simple bit and within an initial beginning block, if I'm going to write down A is equal to one tick binary X and let me display it, dollar display. What happened to this dollar display? The value of B is percentage B comma. Sorry. Yeah. So what is that we are going to get here? The value of A is equal to 0. Can you able to say this? Yeah. Got it. So the value of A is equal to 0. Can you able to see this? If I'm going to try to give X, so basically compiler is converting X to 0. Okay. So if you try to assign the value that is X to your this particular variable, it is going to be converted to 0 and it is going to be stored inside this A. Okay. So this was about your bit. Okay. Now let's say if the next data type which I'm going to have is byte. Okay. Now again, I have few questions here. So the first question is, what is the size? What do you think the size of this byte data type will be? Exactly, 8 bits. As the name itself suggests, it is going to have 8 bits. Okay. Now, what do you think? Is it signed or unsigned? Any guess? Any random guess if you know or don't know? Okay. Basically, this byte is signed data type. Okay. So basically, this byte is signed data type. Okay. So what do you mean by signed data type? Can anyone tell me? What do you mean by signed data type? Can anyone tell me? It can store both positive values and negative values. Exactly. So signed data type can basically store positive values as well as negative values. Okay. Now, so as it is a signed data type, can anyone tell me the range of values it can store? Exactly. Minus 128 to plus 127. That is minus 2 power n2. Sorry, minus 2 power n minus 1 or is it n? 2 power n minus 1, exactly. Minus 2 power n minus 1 to plus 2 power n minus 1 minus 1. Am I right? Yes or no? So the range will be minus 128 to plus 127. Okay. Now, next is default value. What will be the default value over here? Okay. So for two-state data types, your default value will be 0 only. Okay. So you can remember this. For your two-state data types, your default value will be equal to 0 only. Okay. Yeah. Now let us see our byte. Let's say if I'm going to have byte B. Okay. And if I'm going to write down B is equal to uh, greater value 128, and if I'm going to display it, what do you think I'm going to get over here if I run this? If I'm going to give B is equal to 128, what is it I'm going to get? And let me display it in the decimal format itself. 1 minute. Waiting for your responses. Okay, what is that I'm getting here? So B is equal to minus 128. So let's say if I'm going to give 127, let me save it and run it again. See, so if I'm giving out of range, then it is giving some other value which is not we expected. Okay, but if we are giving in range, we are getting whatever we are going to bring. Is it correct or not? Yes or no? Yes, exactly. Okay. Now, let's say if I'm going to provide minus 5 and let me print it. So what is that I'm going to get? I'm going to get minus 5 itself, right? Now, let's say if I'm going to give 1010, sorry, if I'm going to give minus 5 and if I'm going to display it in the binary format and let me display it. So what is that I'm going to get if I'm going to display it in the binary format? So is it correct? Whatever we are going to get, is it correct? So minus 5 is this and we are getting some value. What is this? Can anyone explain? Exactly. This is 2's complement format. Exactly. That is 2's complement of. Yes, yes. Okay. So that is how you are going to use your byte. Now my last question for this particular session. So let's say if I'm going to have bit 7 down to 0, A. Okay. And let's say if I'm going to have byte A. So my statement is these two are same. Is it correct or wrong? Bit 7 down to 0 is a vector of 8 number of bits with the size of 8 number of bits like this. And byte is also 8 number of bits. So what is wrong in this? This both are same, right? Exactly. Exactly. Signed versus unsigned. So these two are not same. No, these two are not same. So this is unsigned and this is signed. Okay, there is a lot of difference in between this. Okay, so this is also one good interview question, frequently asked. Okay, so what is the difference is this two are same or not? Okay, so basically these two are not same. Okay, the first one is basically unsigned and the second one which we are going to write is signed. Okay, yes. So that was yeah, exactly, because it is unsigned and another is signed. Exactly, correct. So that was about your introduction to logic data type. That is nothing but my four-state data type and two-state data types introduction. We have seen like what are all the two-state data types which we are going to have, and we have started with a simple bit data type, and we've also started with our byte data type. And in our next session, we will complete our discussion about short int, long int, and we are going to discuss about structure also. Okay, so we are going to see what do you mean by structure, and we are going to see some enumerated data types, right? So this we are going to refer and start in our next session. Both are 8 bits, but bit 7 down to 0 is in packed array, and byte is not, and bit is unsigned, and byte is unsigned. Exactly. Yeah, about the packed arrays and all, we will discuss. Okay. Yes, yes. Great. Exactly. So normally what happens is, I will tell you exactly where your logic is used. Basically, we prefer it because in our interfaces we are going to use it. We don't know whether we are going to drive it as an output or whether we are going to use it in a logical block or something. So that here your logic will be very helpful actually. Okay. Morning maximum. Okay. Yes. So that's all about this particular session. If you have any doubts or any other queries, you can stay and discuss with me, or else you can